and welcome to a new video on our series in Challenges in Software Development. Today we have two guests that come from the C++ world, and not only. They are also speakers at CppEurope conference that takes place on 25th February 2020 in Bucharest. And without further ado, let me introduce Augustin and Elizabeth. Welcome.
Thank you. It's great to be here.
Thank you.
Okay. So before we start, what would be your background? Tell us a bit about what you have been doing, what you are doing now. Who wants to start?
I can start. So my name is Elizabeth. I'm an engineer on the C++ cross-platform team at Microsoft. I mostly focus my time on our remote Linux targeting features. So that would be using MS-Build or CMake, developing inside Visual Studio, and then targeting a remote Linux machine, whether that's a container, whether that's a VM. Recently, something that I implemented or something that I worked on was our native WSL support. And if you're not familiar with WSL, I think we're going to talk about that a little bit later.
Yes. Let's do that.
And my name is Augustin Popa, and I am a program manager on the C++ team at Microsoft. I've worked on various different developer tools there for C++ developers, including Visual Studio Code, and more recently vcpkg cross-platform C++ library manager.
So one of my favorite questions whenever I meet people with different titles, program manager can mean a lot of things in different companies.
Right.
So can you explain what you are doing that led to this title? Or?
Sure. So I guess the main difference between software engineers and program managers at Microsoft is that software engineers tend to focus on more specific technical implementations of things. They tend to be the ones writing most of the code and actually making things happen, actually building the applications that we are working on. Program managers work more in terms of figuring out what the problems are, what the solutions are, designing the next version of a particular product, talking to customers, talking to engineers, and coordinating things. And just trying to figure out what the best possible product is that you can build for the next generation.
So I imagine for Microsoft C++ is quite also technical role.
Yes. So yeah, I think for sure program managers in what we call the developer division at Microsoft, they are definitely they definitely have to be quite technical because our customers are developers, and we are working with developer tools and developer services. So we do get thrown right into the thick of things in that sense.
So you probably deal also with the new features in C++, and with features that are requested by customers, I imagine, on various areas.
Yeah. So the C++ team at Microsoft is quite diverse in the areas that it covers. So we have people on the team that focus more on evolving the language standard, and they're involved in the C++ standards committee and the various meetings that happen. There's a few meetings every year. And we have people that work on as well the MSVC compiler and standard libraries, and that's also very language focused and actually implementing what's the latest in the standard in an actual in the actual tools that developers can then use.
Just out of curiosity, how many people are approximately in this team?
Overall, it's definitely over 100. I'm not sure what the exact number is right now. It's probably like 90 something devs, or maybe a bit more. Overall, but
I think it's a little bit over 100 devs in total, and then I think it's about an even split between the IDE teams who work on the tools in Visual Studio, and then the compiler teams and the libraries teams. and then a
Right,
couple floating teams like package management
and we don't have a lot of program managers. It's maybe like I should probably know the exact number because it's not that large, but it's probably like 7 or 8 people.
Yeah, the ratio is about 5 or 6 developers to 1.
Okay. So it's
probably
like
a bit more on our team, I think, but close, yeah.
So it's kind of like a medium-sized company within within a large company. That's what it sounds.
Yeah, we also work a lot with other teams across the company.
Yeah.
Mm-hmm.
In a sense, when we think of our customers, we have this. We think of the other engineers within Microsoft, that many of them are also using our tools, so we have to support them and give them a great experience. But at the same time, we have a lot of external customers, millions of developers that are using C++ tools. So we're kind of concerned with that whole space.
Okay. So now it's interesting to hear, and from I've seen this change at Microsoft in the past 5 years or so, and I think you're part of this new era of Microsoft, where we go to a lot of cross-platform and pushing, well, not pushing, but delivering tools that are good for multiple platforms, that provide a good experience and so on. And people know I've been using Ubuntu now for like 12 years or so, and it's been really good. But now I can also have VS Code on Ubuntu, which is again very good, because we have 2 worlds now coming together. So when I saw this about cross-platform, that's very interesting. What do you do with the cross-platform teams?
Yeah, so our C++ cross-platform team focuses really on a couple different areas. We focus on our MS Build workloads, where you can develop inside Visual Studio, and then we'll actually copy your sources over onto a remote Linux device, and then we'll run your GNU developer tools behind the scenes. And so we're running G++, we're running GDB, but then we're surfacing all of that information and the information that we extract from those tools as Visual Studio interfaces. So if you're familiar with developing inside Visual Studio, you get the same experience, and you get all of our tools. You get our profilers, our sanitizers, and all of our full-fledged IntelliSense experience, but it's all happening on this Linux device. And so you get that for MS Build, but then you also get that for CMake, because for us, cross-platform really means you can develop on any platform, for any platform, using whatever tools you want. So you can use GCC, you can use Clang, you can be on Windows, you can be on Linux, you can be on Mac, you can be targeting that machine, targeting a different machine, you can have the same project targeting all 3. Like, we're really setting people up to be able to use our tools no matter what they want to do.
And this is particularly complicated in C++ world. Well, when you have a virtual machine, like for C# or other .NET languages, for Java, it's a bit easier. At least you're targeting the virtual machine. But in this case, you're targeting very different environments. So I imagine you have quite a lot of challenges there doing that. It's also interesting to me that I remember one big strength of Visual Studio was debugging support. And I think now it's probably, you couldn't do many of the things in GDB, or that debugging there is quite difficult. So how is debugging now cross-platform? Does that?
Debugging, there are definitely some features that haven't yet lit up in the Linux scenarios, but all of the kind of the happy path of debugging that you would need in an enterprise project, we have most of that working, and it's this similar fidelity experience that you have on Windows. And so some of the new debugger features come for Linux maybe a little bit later, but all of the things that you would think of as your essential must-have debugging experiences that would drive you to use Visual Studio rather than maybe a different tool, those are all there for Linux.
And what's particularly interesting is, so if you're targeting Linux, you still have GDB running on the Linux machine. But instead of having to interact with GDB at the terminal, you can use the user interface in Visual Studio. And it's exactly the same essentially as Windows.
Yeah.
And you'd think you're just targeting Windows, but really you're actually doing all this stuff on the Linux machine.
And any features that are supported within GDB, we can have that translation layer. So everything is happening for us over SSH. And so everything that we can drive and get from the command line experience with GDB, that can all be done through Visual
Right.
Studio. And we also have a lot of options for custom configuration. Those challenges that you were talking about with cross-platform development in C++ specifically, I think one of the ways that we've addressed that is we give people a huge amount of ways to customize their build processes and their debugging processes. And so a lot of those surface in the form of whether that's a JSON file that we're actually passing to GDB through our translation layers, or we also have this concept of our configuration manager and configuration files for CMake. And so in all of those places, you can really set up the environment that you want, set up all of your custom options, anything that you can tell GDB yourself, we can do it as well.
Okay, that's really cool. How about, so I saw in your talk for CppEurope, you discuss about the various tools that is cross-platform C++ development, and we got into the debugger, but I think there are more, which are the other interesting tools here.
Right. So another big one is, and you referenced it earlier as well, is Visual Studio Code. So we've had, Visual Studio has been around for over 20 years, and it's certainly developed into a very, very powerful IDE. And more recently, Visual Studio Code has popped up, and that one is open source cross-platform. You can actually run it on macOS and Linux. And if you install the C++ extension for Visual Studio Code, which our team works on, you get a really nice C++ experience there. And you can do building and debugging. You get auto-completion and semantic colorization. And there are a number of new productivity features that have made it into Visual Studio Code as well. So it's really shaping up to be a very powerful development environment for C++ that you could also run on your Mac or Linux device if that's your development environment.
Yeah, that sounds interesting. I actually didn't know there was an extension for C++ for VS Code, but that's cool. You also mentioned a package manager. Or something similar.
So another tool that our team works on is a cross-platform C++ library manager called vcpkg. It has over 1,200 popular open source libraries supported in its catalog. The model, the way it works is that behind the scenes, they're all made to basically be compatible with each other. So if you install some subset of the libraries, let's say you need 10 libraries for your particular application, you can install all 10 of them, and you can be generally certain that the libraries will work together and you'll be able to use them. With a few exceptions, it's still a work in progress, but it's certainly a lot better than having to go and install them all manually and build them all manually and figure out, okay, well, what changes do I need to make this actually run, so I can actually run my program.
That's actually a nightmare in C++, trying to get every library and get the right dependencies and compile. But it also gives you a lot of power in terms of options, because you can use static libraries, you can use dynamic libraries, you can do a lot of things.
You can definitely do all of that in vcpkg, and one of the things that we talk about in our demos for our talk for CppEurope are that both of us, we're both using different real-world projects, like big projects, and we've done all of our dependency acquisition using vcpkg. And it's something that's pretty shockingly easy, especially if you sit there trying to manually build all of these libraries and then tell your build system where they are. We have a lot of integration. There's pretty tight integration between the Visual Studio Code, and vcpkg, and so in a lot of cases you don't have to do anything, and Visual Studio is like, I know where all of your libraries are. I found all of them.
That's cool.
Right. And vcpkg is also cross-platform, so if you're targeting multiple platforms, so let's say I need my application to run both on Windows and Linux, you can install the libraries on both sides with vcpkg, and then you'll just be able to get to work.
And depending on the tool chains that you have available on those machines, it'll use the right tool chain so that it's built for that machine.
So Does this work with things like Boost, which is kind of mega
Yes.
library
does.
thingy
Boost is one of the
that
libraries
requires
offered.
its own compilation and its own configuration and its own selection of packages? And
You just have to type vcpkg install Boost, or you can pick a specific subsection of Boost, so you don't have to install the entire thing at once if you don't want to. So that's already there and nicely categorized and on all the platforms.
How about support for unit testing, for other types of automated testing, especially when you do unit testing? At least most of it will be in memory, so I imagine that's easier. But when you are trying to do some kind of integration testing, you're already touching on the OS primitives, on things like this. How does this work?
So in Visual Studio, we have a few features around unit testing. We do have built-in support for so there's the MS-Test testing framework, which Microsoft has provided for a while, and there's a C++ version of that. But then there's also a built-in support for Google.Test and Boost.Test, which are two popular C++ unit testing frameworks. And in particular for the Google.Test one, it even installs a copy of it built in, and you can create a new Google.Test project really easily, and you can say, okay, I want this compiled statically with dynamic runtime libraries, and then you click OK, and then it sets that up for you, and you can start writing tests that target other projects in your application.
Yeah, another feature that to me is very interesting, because we work with clients that tend to have, and especially with C++, you tend to have very large and old code bases that have been written in various styles. And sometimes the team has left and nobody knows anymore, and everybody's afraid to touch parts of the code. And then it's very important to have good support for refactoring. But good support for refactoring in C++ is particularly difficult, because the language is so complex that you can go wrong in so many ways. And I have been checking CLion recently, and the JetBrains IDE. The support is quite limited, and it doesn't always work. I'm curious what's the state. I haven't tried Visual Studio, but I'm curious what the state is for this.
Sure. So I used to one of the areas I used to work on in Visual Studio is productivity features. So I'm a bit familiar with the different refactoring features we have. And also in Visual Studio Code recently, I believe we added rename, if I remember. But that one doesn't have, Visual Studio Code doesn't have as many productivity features as Visual Studio in general, because Visual Studio has been around a lot longer.
Yes.
But in Visual Studio, we do have a few different ones. The big three, as we call them, are rename, extract function, and change signature. And we have a lot of small ones that do more targeted fixes. Like convert to raw string literal, for example. That's like one very specific one. It is very difficult doing refactoring features for C++ compared to one of the common things we run into, I think, is because of course we have teams working on other programming languages within Visual Studio, and we found that it's easier to do something for, say, .NET than for C++.
Yes.
So that's part of the reason, was because we always get the feedback like, well, .NET has all these extra features. Why don't you have these same features? Okay, well, sometimes we have to working with the language and making sure that things work and we don't have too many random errors or bugs when you run the operation. It can be quite challenging with C++. But I think the state of the world has gotten a lot better over the years, and I think it will continue evolving.
Yeah, and to me, especially when I was looking at functional programming in C++, which is also relatively new. And I guess this is another challenge. So keeping refactoring up to date with the standard can be quite complex. And now we have lambdas and all these things. And I really wish for a refactoring that would allow me to select a piece of code and say, extract lambda out of it. But that's, I can't even see that that's very far away from it is.
Yeah, I think over time we'll see more and more features pop up. It's also hard getting a lot of developers using very specific refactoring features, so that some of the more broad ones, like of course a lot of people will do rename because that's such a common scenario. But when you get more specific, either it's hard to get people to discover it, or it's hard to get people in a workflow where they're using it anytime they would want to do that in that change, and people tend to just end up doing it manually. So part of it is also, I think, raising awareness and educating developers on, hey, you actually can do this, and it'll save you some time every once in a while. And you might have to learn how to do it once, but then once you do it, over time it'll pay off in terms of the time you save. And yeah, I think, well, like I was saying earlier, if we compare to where we were like 5 or 10 years ago, I think things are getting a lot better, and they will continue evolving.
Yeah. Okay, you mentioned, I think, running on containers, things like that. How are containers used? Because I've seen, when Docker first appeared, I saw it as a good vehicle for, installing Docker on your machine, starting to develop there, also including the configuration, and then basically shipping the container all the way to the server. But what I've heard from more programmers is that it's quite hard to develop for a container on your machine. What is your experience with this?
So right now, containers is something that's on our backlog, and so our container specific workflow is more so treating it as a VM right now.
Yeah.
And so that's something that's coming in future releases of Visual Studio.
I think, and also for Visual Studio Code, I think.
Yeah.
But containers have definitely gone up a lot in popularity over the years, and it's definitely something we're starting to pay a lot closer attention to.
Yeah.
We don't have a whole lot in terms of making the experience easier, like you were saying earlier, we're kind of treating it like VMs. But I think over time, if people follow what we're working on, they'll start seeing some new features come in that can help them.
Yeah, we're seeing a lot of potential there, especially with things like creating repeatable environments for deployments and creating repeatability for integration testing, something that you mentioned earlier that we're starting to focus a lot more on, because a lot of our customers are coming to us and saying, we're running CI builds, like we need these tools to be automatable, we need them to have test integration, and Docker is a huge tool for that. Right,
and one specific area that I'm looking at right now is around toolset acquisition. So there's mentioned kind of library acquisition, where I'm working on vcpkg with that, but there's also toolset acquisition. How do you actually get your build tools up and running? And that includes considering, well, how does that work in a world where you're dealing with containers? So that's something I'm looking at as well, because traditionally the way you'd install, certainly the build tools that Microsoft provides, is you'd go and install Visual Studio. And you'd install many gigabytes of packages to some centralized area. You probably need to have admin access to install that in the first place, and it can take a while, and it's one monolithic thing. You probably only need some piece of that, but you get all of it at once anyway, and going through that process is not ideal. So we're thinking about, okay, how can we actually break down the components so you don't install something massive? How do we make it so you can do non-elevated installation? How do we give users more control over exactly which packages do you need, and making sure that everything is repeatable, and that it can be systemic across your development team, making sure that everyone gets exactly the same tools, exactly the same way, exactly the same versions, and that there's a way to control that and update that over time very easily.
Yeah, and that's particularly interesting for C++, because with so many complex dependencies and different tools, and maybe, I don't know, maybe you have somebody using Vim and trying to run a command line build or things like this.
Yeah, exactly.
Which can happen. We just had an interview with Joe Yoder, who has been very active in the design patterns community for 20-something years. and he's seen a lot of things. And one of the things he was talking to us about was he once saw a C++ class that had 500,000 lines of code. And that was at a very large company in the US. And they couldn't open it anymore with Visual Studio. So they actually had to open it in Vim or Emacs or something like that, and then go into it and very slowly refactor it little by little. So, and there are situations like this in C++ where there are things that you don't expect. I remember when I was still doing, I was working on a C++ product. It was probably 15, 20 years ago. But back then, at one point, we got an error in Visual Studio in build saying us that we had too many build errors. So the error was that we had too many build errors. So there are all kinds of things like this that you see in this complex world. And but to go back to cross-platform, do you think about things like embedded software or appliances, firmware, stuff like this? Because especially here in Romania, we have a lot of teams working specifically on these things. We work with teams who build firmwares for electric meters, so very small memory. We work with teams who are building like entertainment systems for cars in C++, and those are also some of the very big challenges with C++.
We definitely think a lot about the embedded scenario, and we love our IoT developers, and that was one of the customer segments that we had in mind when we started down this path of how do we provide Linux tools, where people who are developing on Raspberry Pis, people who are developing these IoT applications. And then when it comes to embedded, we also have something called Azure Sphere that I think is definitely worth mentioning, where we have these secured chips that Microsoft is now manufacturing for IoT scenarios, and we have them in Starbucks coffee machines and a couple other places. And our team, or a subset of our team, are the ones who are building the developer tools for these chips. And so for people who are developing for these secure chips, they're actually using a subset of the C++ cross-platform tools that we use.
Okay, so that's those are some very specific. We also worked at one point with a customer who was building like a very precise timer, and part of it was real-time C code in that case, but they were also looking at C++, so it could have been C++, but they were trying to refactor. So these scenarios are quite interesting. How about games? Anything in that real-time world gaming?
Sure. So a lot of game developers are using Visual Studio today. They're an important market for us. We've been working on a number of different things. Today in Visual Studio, there's game development with C++ workload. There's also another one for Unity with C#. But for C++, you can. That's kind of an easy way if you're targeting Unreal Engine or Cocos 2D as well. I believe is provided by it. It's an easy way to get up and running in those kinds of environments. Of course. Especially for Unreal, there are other things you need to install. Unreal has like its own build process, its own development environment that would work side by side with what you do in Visual Studio. So we work a lot with their team, making sure that whatever we do doesn't break them, and that that Unreal developers get a good experience. We actually meet with one of their devs. We have like a regular meeting, and we sync and make sure that there's some new compiler bug was introduced. Let's get that fixed really quickly. That kind of thing. So
imagine is very important. Okay, how about multi-language projects? Like you have C++, but often with C++ you have Python or Lua or all kind of.
in terms of our tools, we do have some. We've definitely seen a lot of developers doing C++ and Python, as well as C++ and C#, particularly in Visual Studio on the second one, because Visual Studio was already had C#, already had C++, and you can just work in that same environment across both of those languages. And we have an interop layer there. Well, there are a few different ways you can use to do cross-language development, but usually the recommended way for C++ and C# is something called C++ CLI.
Yeah.
And that's kind of yeah. So it's like an interop layer, so you can communicate across those language boundaries. And that's something that we're continuing to maintain and make sure that it works for people, so that they can have maybe some of their UI-facing code in C#, for example, and something that needs to run in the background at high performance at scale in C++, as an example. And in terms of Python, we've been investing a lot in our experiences there. I'm not on the Python team, yes, so I don't want to represent them too much. But I know certainly in Visual Studio Code, it's a very, very popular environment. There's also a Visual Studio experience for Python. But yeah, and in Visual Studio Code, there are many developers who are using Python today, and then you can install extension for that, and there's also a C++ extension for C++, and you can work and use the same kind of user interface to get work done for both of those scenarios.
Okay. You mentioned something called WSL, which I have no idea what it is. So.
All right.
I'll let her speak to that.
So WSL is the Windows subsystem for Linux. And so it's this Linux command line tool that's available with Windows 10 and later versions of the operating system.
Now I know what you're talking about.
There we go. It used to be called Bash for Windows, so people might know it as Bash for Windows. But we're really encouraging a lot of our C++ developers to try out cross-platform things. And one of the easiest ways to get them to do that is a lot of developers are already familiar with Linux command line tools and wish that they could use them on Windows, but for some reason or other, they're on Windows. And so we're giving them this harmonious experience of you have this Linux command line that can see your entire Windows file system. And so you can interact with all of your Windows files using your favorite Linux command line tools. And the other thing that we've seen people using it for is a way to prototype Linux code really, really quickly. And so the way that our remote targeting for Linux works is that we have an SSH connection that we establish, and then everything that we're doing is actually on the remote machine. And so that naturally means that we have to have a synchronized source tree present on the remote machine. But if you're developing in WSL, that's not true anymore, because your Linux system can see the entirety of your Windows file system. So there's no more synchronizing sources. Even if it's incremental, it's still so much faster. Yes. And so they've recently announced something called WSL2, which is instead of having this translation layer for the POSIX commands to the Windows syscalls, we now have the actual Linux kernel running in a really, really lightweight Hyper-V VM. And so that's a new experience that's just coming out to general builds now. And we also support developer tools for that. And so we have the ability to target WSL as a virtual machine, and then we also have this native support where you can leverage things like the visibility into the Windows file system.
Yeah, one of the things that we did when we were developing products for customers and for ourselves, one thing that I really cared about was to have the same environment on our machines as on the server. So that's why we standardized on Ubuntu. Everybody had Ubuntu machines. The server was Ubuntu server. At least we know that we are, and the same versions. Of course, server version for server and so on. But at least we knew that we are using kind of the same things. And it makes life so much easier just knowing that. So it's really good to hear that in this case, if you are using maybe a Linux server for certain workloads, Windows server for other workloads, you can at least use the same tools, right?
Right. And the world I think we want to move to is a world where developers are free to choose individually what tools they prefer working with and what environment they prefer working in. but still being able to work as part of a larger team where someone else on the team might like working on in Ubuntu, but they might like working in Windows and Visual Studio using the Visual Studio debugger, and things still work, and they don't have to do a lot of extra work to make everything to make sure that their code actually builds and is correct.
We're also doing a lot of work, I think, to I think a lot of the issues, or some of the issues that we saw with people using MS Build, was that it was very, very tied to Visual Studio, and it really wasn't meant to be edited by individual developers behind the scenes. But now we have build systems like CMake that are really made for this level of customization, and so a lot of our new tools are kind of focusing on differentiating your build processes from Visual Studio, so that you're in Visual Studio because you have tools you want to use there. You can take your build, you can take those same build scripts and you can open that same project in VS Code, and you're not tied to one specific editor. And so I think that really plays into our idea that you should be able to use whatever tools you want, and whatever tools are well suited for the job that you're currently trying to do.
And CMake is really nice because it can use different build drivers behind the scenes, so you can customize it to whatever you want. If you want to make files, you can make it do that. If you want MS Build, you can do that. Or use Ninja and get nice performant builds going. Different options are available.
Yeah, and I remember one thing that I really care about is when I'm moving into a continuous integration machine or something like this, I want that to run with minimal code, minimal outside installed packages. So I'd like to have just my build script and my build tools, and just build and the dependencies and build the stuff, run the tests and so on, without having a whole lot of baggage around it, because you never know when you go to production, does this still work? You know,
absolutely.
Maybe there is a dependency that's somewhere hidden that somebody uses somehow. You have no idea, and when you move to production, you realize, oh, yeah, we are missing something, and yeah. So it's great to hear.
And that's an area that we're actively looking at as well. In the past, we've really focused, I think, on what is the developer experience on your developer box? But now it's more about, well, it's not enough to just think about I'm running builds locally and testing things locally. What about continuous integration? What about containers? You have to look at a much wider world, and we're looking at things like, okay, how should we actually acquire the build tools and the libraries that you need for your code in a very deterministic way that gives you the smallest packages you would need, and a way that you can replicate that everywhere. Including in your continuous integration system, and it's done exactly the same way as on your local developer machine. So you know that, okay, I set up my local developer machine a certain way, and I got everything working, and I checked in some code, and I know that when that goes to the CI machine, that everything is repeatable, and I'm not going to get some weird error because, oh, actually, this was installed differently on this machine, so you need to go and fix that.
Yeah, I would definitely add to that we're working specifically on our team. We're working to add command line interfaces to a lot of the functionality there, which is basically, if you have a CI machine, like, why are you spinning up Visual Studio on it necessarily? You should be able to drive all of those builds from the command line. You should be able to interact with a lot of our libraries outside of Visual Studio.
And originally we had Visual Studio, this one giant monolithic thing. Then in Visual Studio 2017, we went and really broke down the components and created a new installation experience, so you didn't have to install as many things. And then we had the Visual Studio Build Tools SKU, which is essentially kind of like a lightweight version of that, where you don't get the IDE, you just get the build tools. And now we're thinking about what's the next generation going to be? How do we make that even better? Can we have a nice command line experience for getting all of the tools that you need? And not getting large monolithic packages, but getting very specific things that you know you need, so you don't have to install gigabytes on your machine unnecessarily.
Yeah, so I have a suggestion. We are meeting from time to time in an informal group that we call Software Development Gang, just because we couldn't find a better name. And it's a group of people who are advanced and typically work already mastered as driven development, refactoring, all these things. And we discuss some of the problems that we face. And one common problem is the problem of legacy code. And you have a lot of code you need to refactor and so on. One thing that we keep bumping into that is missing in modern IDEs is not only support for refactoring, but for support for scripted refactoring. Because maybe I want to do, so I figure there's often the case that people write code in specific patterns. And then if I go into a file and I do some changes, some refactorings, I would like the ability to replicate this, maybe semi-automated on other files and kind of see the results and see if I do this set of refactorings, then I'd go to another file and another file, what do I get? And so on.
Is this kind of like a build your own refactoring?
More or less, yeah.
Engine.
It's very useful for large scale things. So things like I have 2,000 files that maybe have been written in a relatively the same manner. It's quite consistent, right? Because we tend to, especially in C++, we tend to follow rules, but this applies to other languages. But then there comes a time when we realize, oh, now we have other patterns that we can use. And you have the option of going into every file and changing it manually and kind of doing the same refactorings over and over again. Or going into one and saying, let's make this refactoring script. We will do extract some functions, we'll do move to another class, we'll do all these things. And then let's apply this to the whole code base, and probably it won't work from the first time, but at least most of the work is done and that you just need to go and fix specific things. So that would be, to us, is kind of like the dream tool for a lot of the work that we do. And it goes into a very difficult problem, which is this existing code that kind of stays frozen because you don't have the time to go there. And
sounds like maybe a direction for IntelliCode.
Yeah, could be.
Maybe. Is some of this like code style and formatting, or is some of this just every once in a while I realize I need to restructure my classes and move some code around?
It's actual refactoring, so not refactoring, not to reformatting, but refactoring. So things like extracting methods. And we often see, so for example, you used one specific framework and you want to move to another specific framework or another version of the same framework. And there are patterns that you've used all around the code. And now when you want to switch to the new version, there are new patterns that you need to switch to. And you need to go manually again into each file and switch. So these are some of the use cases for this, and it would be quite interesting to see it. You mentioned IntelliCode.
I did mention IntelliCode.
Yeah,
so
tell us a bit about it. It's interesting.
IntelliCode is actually not something that my team works on, but I think it's a really cool thing that we're doing. The team just adjacent. Actually, no. We're cloud and we're cloud and cross-platform now. So we include IntelliCode, and so basically what it is it's an AI-driven IntelliSense engine, and so we allow you to, or the first generation of this feature was that it would train itself on some code bases that we had in-house, and then we would ship it out, and it would learn things like existing patterns, and it would suggest things like, oh, if you're instantiating an iterator, we want begin, we want end, we want these things that you're probably going to want in 90% of cases. And so when you see that autocomplete list in the IDE, it would pop up these guesses at common patterns with a star beside it, indicating that it was coming from the IntelliCode engine, basically just trying to give you more intelligent suggestions and speed up your productivity. And I think a really cool feature that we're coming out with now, and that we're coming out with specifically in C++ now, is custom models, which is train it on your code base. So whatever style you like, cool. whatever patterns you are actually currently implementing, you can say, hey, I want to train this model on my own code base, and then we can have intelligent suggestions that come from our design patterns. Yeah,
that would be really cool. Now to switch gears a bit, because we discussed a lot about the tools, and it's been very, very interesting. But I'm also curious about how you work. So what is your daily or weekly, or what kind of practices you use, what engineering practices, how do you organize? whatever you can tell. Maybe there are secrets, but what you can tell. That would be interesting.
I mean, one of the things that I would call out is how focused we are and how driven we are by our customer feedback loop. So we have a website called Developer Community, and so a huge amount of the prioritization and the bugs that we get to fix and the features that get implemented are driven by our community. And so you can go onto this website and upvote, and there's a certain amount of upvotes where it's going to come to our attention and it's going to be a priority for us, and it's going to come out within a release or two because enough people in the community care about it. And so that's something that I would share about our process specifically, especially for bugs.
So that's one way of doing. Is that the only way of prioritizing, or you also have a team that kind of goes into?
Yeah. So we have there are a few different factors that impact how we prioritize something, and also we think of bugs and features differently as well. You can suggest features as well on developer community, and you can also report bugs. So reporting bugs falls on the quality side of things, which we always want to maintain a certain bar for quality, and we want to maintain a certain bar for performance and reliability. And for feature work, it's a lot more abstract in terms of like, well, how do we decide what to do versus what not to do?
Whenever we talk about the difference between software engineers and PMs, I think the reason why we deal with them so separately is that bugs, it's very, very easy to say this is wrong and I wish it wasn't wrong. This behavior is not right. But then with features, a lot of the time when people are requesting features, it's because something in the workload is not designed maybe quite right. And so that's the reason why we have PMs, and one aspect of why we have PMs is because they look at these problems and they're like, this person keeps telling me that they want this thing, but would they still want this thing if we had something that made sure that that wasn't an issue to begin with? And
when I've been dealing particularly with that a lot.
Yes.
Where we get a lot of feedback about a few very specific things, and people love to also suggest, well, I think you could fix it by doing this. But then when we look at it behind the scenes, we realize, well, actually, doing that would not be that simple, and we have to think about all these other scenarios and how those people are impacted. And when you have millions of developers that are using your product, you have to be very careful when you make a change to make sure that you're not negatively impacting other people. Or you have to think about, okay, how do we make this feature also light up for this other scenario that maybe this particular person is not interested in, but this other person is interested in. And we end up having to iterate and change the plans and design and redesign things a lot before we get to a point where we realize, okay, this is actually something that can be broadly used.
Do you still use personas? I remember in Visual Studio, it was one of the first places where I saw things like developer personas.
I'm not sure what you mean by personas in this case.
So persona, it's a technique of basically structuring your users. By giving them a name, giving them the general characteristics. So you would have something like the old C++ developer who's been doing this for 30 years, who, I don't know, knows a lot about the fundamentals and so on, can use Vim maybe. So that would be a kind of persona. And then you have another type of persona, which is, I don't know, the new developer who just learned C++, is now starting, he's excited, they want to. Do you have something like that?
I think we loosely do, where we do a lot of data collection of who's actually using our products, and then we think about who might be using our products and why they aren't. And so I think sometimes it's helpful to talk about those people as real people and say we have a whole sector of students that, for their parallel programming classes, like maybe they should be using our Linux workload, and why aren't they? And so
and I can speak to that a little bit as well. I think we do segment developers in different ways, and sometimes we change the segments depending on what we're thinking about. One common way we segment developers is as students, hobbyists, and enterprise, because they tend to have very distinct needs. In the past, we've prioritized enterprise developers a lot for Visual Studio, because Visual Studio is used by so many enterprises, and they're the ones who get like the premium VS Enterprise license, and they get the premium support agreement with Microsoft, and we have to pay very close attention. Don't break anything for them. Make sure everything works great. But then we also think about, okay, but you have this product that's very, very complex and has a lot of different features, many hundreds of features. How do you make that easy to use for somebody who is just getting started with programming? You're a student learning C++. What do you do if all of this stuff is thrown at you all at once? So one of the things I was looking at about a year or so ago was the getting started experience for C++ in Visual Studio, and we realized a huge number of students were trying Visual Studio, much more than we ever expected, considering how much we focused on enterprise developers in the past. But that's because these students do want to become professional developers, and they want to be using the tools that professional developers are using. So then we had to think about, okay, well, what are the common problems they run into? And we had to go back to really basic things, like maybe the console window shouldn't close itself when you finish a debugging session, because it was just doing the classic Windows command prompt thing where, well, I finished running this script, and now it's just going to close itself because I don't need this window anymore. Because it's done its job. The problem is, if you're trying to print hello world, you want to actually see the hello world. You don't want it to disappear.
I remember that.
And the new programmers don't necessarily know how to.
And I had to push a lot for that to happen, because people were concerned that, well, if you change such a fundamental experience in the product, how many people are going to complain that you changed that fundamental experience? And it took a lot of sitting in a user experience lab with students and watching them struggle at the start and trying to figure out, and having to go to a search engine and search, like, why did the console window close itself? And then they pull up a Stack Overflow post with dozens of upvotes and a lot of comments saying, well, you're supposed to do this, but you wouldn't know that until you go through that workflow. So little things like that can actually add up, and we've made a number of different tweaks here and there that actually make that getting started experience a lot easier. And there's still a lot more work to do, I think. Yeah. And it's a hard balance to maintain, because we can't just start taking out many features to simplify things, because then the enterprise developers will say, well, what happened? I needed this.
Yeah, of course. We were talking about the debugger before, but I haven't used the debugger I probably open it once a year ever since I started doing test-driven development. I don't need the debugger anymore. It's good to know it's there, but it's very rare that I use it. But I imagine I remember when I was doing C++ before mastering test-driven development. Yeah, that was a very important tool in my. So yeah, I can see how it's not easy to pick the features depending on the audience. Right. Do you use any kind of sprints or something like that in your development, or how does it work?
Yeah, so I think it really depends on the team at Microsoft, for sure. Some teams adhere pretty strictly to agile workflows, and some teams are a little bit less. Since our team is still fairly new, we're actually in the process of iterating pretty heavily on a lot of our bug triage processes and our feature allocation processes and that kind of thing. And so we've been trying out a couple different methods. And so we kind of loosely use sprints, but we adhere much closer to our release schedule, which doesn't match up exactly with sprints. But we generally have two different phases. We have bug-focused phases and feature-driven phases. Sometimes those two mix in together if we have an external dependency that requires something land at a certain point, or an insertion that needs to happen. But generally we'll spend the first couple previews of a release working on features, and then we'll focus on stabilization and bugs for the next set of previews, and we'll restart that process about every month and a half or 2 months.
Yeah, and to add to that, even within the C++ team at Microsoft, there are different processes for different teams. So for example, for Visual Studio, we have to be very careful about everything we release and make sure that we don't introduce something that just breaks 200,000 users. That's not good.
Of course.
So we tend to be very careful, and we have a very structured process. And we have certain release schedules, and they change all the time because sometimes we find that, well, we really need to focus on quality and getting a bunch of bug fixes done. And sometimes we say, okay, we really want to land very big features. We have this big conference coming up. We want to announce them. And so we focus more on that. And it tends to change. And there's a specific place you go to figure out, okay, what's the process going to look like for the next few months, and you can't expect it to be the same because our needs change over time. And I think for some of the newer products, like with Visual Studio Code and vcpkg, we can iterate very, very quickly. Like with vcpkg, we do monthly releases. Everything is basically set up as a sprint because we know at the end of the month we're going to have a new release, and that's just how it is, and that's going to be made public. People will be able to use it. So we have some of that as well.
How about the testing? Is there anything tested automatically?
Yeah, so we use a lot of Azure DevOps testing functionality, and so we have our unit tests and our integration tests and our end-to-end tests running in those CI environments.
Okay.
Yeah. There's a bunch of interesting challenges there when it comes to cross-platform workload testing, because
I was just thinking of that.
Managing the automated testing of something against VMs. One of the things that we run into is that when you're provisioning VMs, if you don't provision them with enough memory to actually run the things that you're testing, or if you're experiencing a lot of drain on your system, then you're going to run into timeouts, and they may be product bugs, but they may be just your VM is not having any resources allocated to it. And so we're continuously working on better processes to be able to flag what are connection issues, what are networking issues, and what are product issues.
Intermittent failing tests are the worst.
It's the worst.
The worst is the Heisen test, so the test that fails. But when you try to look at it, it doesn't fail anymore.
The Schrodinger's test, yes. we know about those.
So these are okay. So we are getting to a close. I think it was a very interesting discussion. Before we close, do you have anything else you'd like to say? Like, where would people go to see some of the developments, or anything else about what you do, or that you'd like to mention?
I have something that I definitely like to say, and that's that all of the features that I'm talking about with the cross-platform C++ workload, they're all available in Visual Studio Community. So you don't need an enterprise license. You can download the free version of Visual Studio, and you can try out everything that we talked about today.
Okay, that's cool. Augustin, anything?
Yeah, so I guess another area that we've focused on a lot as a team is thinking about collaboration and how, not just thinking about an individual developer and what they're doing, but how do they actually work as part of a larger team. And we kind of think of a developer inner loop, which is the stuff you do on your local machine, from authoring code and editing it, to debugging it, and building it, and actually checking it into your source control. But then there's the outer loop. Okay, so now it goes to your continuous integration server, and it's running a bunch of tests, and everything needs to light up. And other people need to be able to go and make some changes to the code you made sometime in the future. And what does that process look for the wider team? So we're investing a lot in better integration with things like Azure DevOps and GitHub, for example, to create that nice environment for working with other people. And we have even features within Visual Studio like Live Share, which lets you kind of stream whatever you're doing on your development machine to somebody else, and they can help you and you can work together on stuff, and you can step through code, and the other person can control that, even though it's happening on your machine. And they don't need to have anything installed on their machine. They just kind of goes to them. And those kinds of things. And a lot of it is still a work in progress, and there's a lot more work we can do in the future. But we're definitely very excited about it. And yeah, that's another way we're really looking at how do we make developers as productive as possible.
Okay.
And that's one thing to consider.
Well, thank you very much. This has been a very interesting conversation. We found out new things. So I hope everybody enjoyed this video. We'll come back with new videos, so don't forget to come back and visit our channel. And until next time, remember to think, design, and work smart.
Coming next.
And a lot of the failing of my customers' processes, and occasionally I was involved, on a process level, is that we didn't really validate that the software they were paying for was needed. Now, agile software development has helped a lot with that, avoiding waste, but still, a lot of the agile software development was doing pretty well on, minimizing waste on the stuff we were doing and making technical practices good. These are all very necessary things, but maybe failing on being sure that that particular user story needs to be there. And the more I thought about it, the more terrified I got of, okay, I'd come to terms with the idea that I'd worked on whole systems that were just never used.